Hello, this is chapter 7.2 and we're solving exponential equations and inequalities. So let's look at what our objectives are. Our objectives are we're going to solve exponential equations and we're going to solve exponential inequalities. All right, so let's go with our first vocabulary word, exponential equation. It just has variables that occur as exponents, okay? So here's a key concept box. This is important. You need to know these properties. So the property of equality for exponential functions says, let b be greater than 0, but b cannot equal to 1. So it says it has to be positive, any positive number except 1, basically. So if b the x is equal to b the y, if and only if x equal y. So what that says, if you have 3 the x equal 3 the 5, 3 the 5th power, then x equal 5. All right, so let's try solving example 1. So example 1 says, sorry, I'm going to get to my, all right, so example 1 says, let 2 the x equal 8 cubed. Okay, so we have an exponent and we have an equation. Well, in order to solve this, we have to have the same base. Okay, b is your base. All right, so you should know that, whoopsie, 2 cubed is equal to 8. So all I did was I took 8, put in parentheses, and then I renamed 8 to say 2 cubed. Now remember, this is where you have to know your exponent rule. So this is the power of power rule, which says you multiply the power. So x to the m times n. Well, we're going to do the same thing here. So we have 2 to the x equal 2 to the 9th power. Since I have the same base, they're equal if and only if x equal 9. Right? Got to know your exponent rules. Told you this is going to be really important. Let's look at b. We have 9 raised to the 2x minus 1 equal 3 to the 6x. Okay, I'm going to put my bases in parentheses. Well, you should know that 9 is 3 squared. All right, so now I have a power raised to a power. Now, you have two terms, so when you take a 1 term times a 2 terms, you distribute. So you have 3 to the 4x minus 2 equal 3 to the 6x. Well, now my bases are the same, so then I can make the powers equal each other. Now I have an equation that I can solve. Minus 2 equals 2x, and x equal negative 1. All right, pause this, do guided practice 1A and 1B. All right, let's look at the real world example. So number 2, it says, oops, let's go to that. Okay, so let's scroll down here. Kristen starts an experiment with 7,500 bacteria cells. After 4 hours, there are 23,000 cells. Write an exponential function that can be used to model the number of bacteria after X hours, if the number of bacteria changes at the same rate. So what we've got going on is we said at 0 hours, we have 7,500 bacteria. So that is going to be our y-intercept, bacteria. And it's also going to be our a. So remember, we use the equation y equal a times b to the x. So we know that a is equal to 7,500. And we know that, so we start here. What else do we know? We know that after 4 hours, so b to 4 hours, because time is the exponent, there is 23,000 cells. All right, so we can solve this. We divide by 7,500 and we get 3.067 equals b to the 4th. Now, we learned this last time. We take the fourth root, and we get b equal approximately 1.323. All right, so now our equation is y equals 7,500, because that's our a, times 1.323 to the x power. So there's our exponential function or equation. Now part B of this says, A just says write the equation. B says how many bacteria cells can be expected in the sample after 12 hours. Okay, so we want to know what y is when x is 12. And all we do is we put it in our calculator. Okay, one mistake is you cannot multiply 7,500 times 1.323 and then raise it to the 12. Remember, this implies multiplication. This is an exponent. According to operations, exponents come before multiplication. So make sure you take this and raise it to the 12th power before you multiply it to 7,500. So then we get approximately 215,665 bacteria cells. All right. Go ahead and pause it. Do guided practice 2A and 2B. Now, we're going to move on to interest. Now, exponential functions are used sometimes in situations that involve compound interest. So let's look at this key concept box. You can calculate compound interest using the formula A equals P times 1 plus R over N raised to the NT, where A is the amount in the account after T years, P is your principal amounts, what you started with, what you invested, R is the annual interest rate, and N is the number of periods that are compounding in the year. So let's look at example 3. It says an investment company account pays 4.2% annual interest, compounded monthly. If $2,500 is invested in this account, what will be the balance after 15 years? Okay, so let's start with our equation, and we're going to have A equal our investment money, invested amount is $2,500 times 1 plus our annual interest rates 0.042, compounded monthly, so there's 12 months in a year, raised to the 12t. All right. So they want to know what's the balance after 15 years. Well, we replace t with 15. Divided by 12 raised to 12 times 15. We put all this in our calculator and we get approximately $4,688.87. All right. So you just got to know, remember, you've got to put this in first and then you multiply by 2,500. Okay, pause it and let's look at the last section. Do the guided practice 3. All right, so the last part is just a property of inequality. Look at the key concept box, and I want you to know and be able to answer the difference between an inequality exponential function and an equality. All right, so here it says let b be greater than 1. Then b to the x is greater than b to the y if and only if x is greater than y. And vice versa, if b the x is less than b the y, if and only if x is less than the y. So let's look at the example 1 or 4. It says solve this inequality. So you see the difference? The difference between equality and inequality is b is greater than 1. B cannot even be a fraction. And equality, b is greater than 0 except for it cannot equal to 1. All right, so let's do this last problem together and then you can begin your homework. All right, so solve 16 raised to the 2x minus 3 less than 8. Okay, in order for this to be true, it has to have the same base. So I know 16 is raised to the 2 to the 4th. right? Because it was raised to the implied 1. So now I have the same bases, and I can use the power of power rule. So 2 to the 8x minus 12 is less than 2 cubed. So we have the same bases. This inequality is true if and only if the powers are set, this side is less than this side. So if 8x minus 12 is less than 3 plus 12 plus 12, 8x less than 15, and x is less than 15 over 8 is simply your solution. All right, stop the video, do the last two guided practice, and I want your notes out on your desk when you get to class.